Hello everyone. In this video, let's get down to solving some problems on understanding the working principle of induction motor. So, in the previous few videos, I have been explaining the theory of how the induction motor works. Now, let's solve some numerical examples so as to strengthen your understanding. Okay, so the question you can see on your screen, which is example 34.1 taken from the book Electrical Technology Volume 2. I will leave the description of the book in the information about the book in the description. So let's solve this problem. Okay, a slip ring induction motor runs at 290 rpm. So this 290 rpm is obviously the speed of the rotor. So I am writing straight away NR is 290 rpm at full load. Okay, this is at full load. When connected to a 50 Hz supply, so my F is 50 Hz. Determine the number of poles and slip. So I have to find what is P and what is S. Now immediately you will find a problem, like if I want to find synchronous speed, it is 120 F by P. So F is given, but P itself is not given, and therefore it's not possible to find what is the synchronous speed. However, we can just simply guess it. What happens is the rotor is rotating at 290 rpm at full load, which typically at full load, which is not exactly equal, but will be few percentage points away from the synchronous speed. So this is a problem of guessing. See, for example, if I take P equal to 2 poles and then frequency is 50 Hz, what is my NS? So 120 into 50 divided by 2. So let's calculate that. Okay, so 120 into 50 divided by 2. So 3000 rpm. So this is the synchronous speed if number of poles was 2. However, if you see here, 290 rpm is given in the question at the full load. So 290 is quite far from 300. So this obviously 2 poles cannot be the answer. So if I take P equal to 10 pole machine, then what do we get? NS equal to 120 into 50 divided by 10. What is that? So 120 into 50 divided by 10, we get 600 rpm. Okay, 600 is somewhat closer to our 290 rpm, but not as close. Okay, so with that same, by the way, it looks like we are doing trial and error. The problem is designed in such a way that only trial and error will be useful to find the correct answer. So now let's say poles are 20. I just calculated it. So 120 into 50 by 20, that will be 300 rpm. So now these two values are closer, 300 rpm and 290 rpm. So maybe the poles are 20. If the poles are 20, then what is my slip? Okay, so slip is nothing but NS minus NR by NS into 100. So we get 300 minus 290 divided by 300 into 100, which will be 300 minus 290 divided by 300 into 100, which will be 3.33%. So typically this is the slip we get it when the motor is at full load. Okay. So the answer to the question, the poles are 20 and then slip is 3.33%. So there's some trial and error involved in this question. That's why I try to include this question. Okay, so let's solve more problems in some more videos.